Well, good day to you folks. This is Mr. Von Ah, and we are continuing our lessons on algebra. All right. So I hope these videos are helpful to you. Don't forget, in the description below on this video, there is a link that you can click, and it will take you to the notes for this lesson. In fact, you'll be able to get all the notes for all the different lessons I've been doing. All right, so without further ado, let's just jump right into our lesson today. Our objective is that students will be able to solve systems of two linear equations, by graphing. All right, so kind of my purpose here is to help you see visually what's actually happening when we solve systems of equations. All right, so what is a system? All right, think about the human body. The human body is made up of many different systems, right? Can you think of a few of them? All right, you got the circulatory system, the respiratory system, the immune system, you have the skeletal system, the muscular system, right? The digestive system, the endocrine system, right? All these systems that we have. And why is it called a system? Well, because each system is made up of many different parts, many different organs that perform a common task, or they have a common goal, right? For example, your circulatory system, the heart, the blood vessels, all of it works together, what? To get blood throughout your body. Thank God for our circulatory system, right? So in algebra, we can take the same idea of a system, many parts performing one function. In algebra, a system of equations is two or more equations that have a common solution. All right? So a system of equations is two or more equations that have a common solution. All right, and so we're going to solve a system here graphically. I have my little coordinate grid system there, and I'm going to put up a problem here. And I want us to solve the system. What's the system? Well, I haven't given it to you yet. All right, here it is. Y equals x plus 1. There's my first equation. Okay, but remember, a system is two or more equations. Just like your systems in your body are made up of more than one organ. All right, so I'm going to have another equation here. I'm going to get y plus x equals 3. All right, so there's my two equations. Together they form a system, and they have a common solution. What is that common solution? Well, that's what we're going to find out right now. All right, so let's go ahead and start with the very first equation. All right, this is in what we call slope-intercept form. Okay, we really haven't gone over how to graph linear equations. We'll go into that more in depth later in another video, but for now I'm just going to kind of skim the surface. So you can graph any linear equation in this form. I'm going to get a different color here. Y equals mx plus b. All right? So I have these two numbers that I'm going to have in my equation. Right? So m, that's going to be my slope. Or another way to think of slope, slope is just the degree of slant. Right? So I have a ruler here. There's pretty much no slope there. I have a little bit of slope there. More slope, more slope, more slope, right? So the slope is just the degree of slant, or another way to think of slope is just the rate of change. How fast is the rate of change on this slope? For example, if this was time and money, if I had time here and money here, right? Well, if this was income, my source of income would be changing rapidly, right? If it was like this, well, my income is changing very slowly, right? So you can think of slope as just the rate of change, okay? It could be distance, it can be time, it can be money, whatever it is you're talking about, right? In this case, we're talking about distance. All right, so m, that's just that's coefficient, that's gonna be some number. Like, for example, here, what's your m? Well, there is no m, is there? Well, actually there is. There's a 1 there, right? So my slope would be 1. All right, how about this b? B represents my y-intercept. My y-intercept. What does that mean? Well, that's where the line intercepts or crosses the y-axis. If you look here at my coordinate grid, I have an x-axis, I have a y-axis, right? So the y-intercept is going to be where it crosses the y-axis. So for example, right there, the y-intercept would be positive 2. Down here, the y-intercept would be negative 3. All right? So if I know my slope and my y-intercept, I can graph any linear equation. All right, so let's take a look at the first one. Okay, I'm going to use this color here. So y equals 1x plus 1. Okay, my slope is 1. My y-intercept is also 1. Okay, so here's how I graph these. I start with my y-intercept. My y-intercept is 1. So I'm going to come over here, and I'm going to say, okay, there's where it's going to cross my y-axis, right? At y equals 1, it's going to cross it either this way or this way, okay? So there's my first point. Okay, but I need at least 2 points to graph. How do I find that second and third point? Well, I use my slope. If you, I'm not sure if you know this, but slope equals rise over the run. What do I mean by that? Well, rise just means up or down, right? A positive rise would be up, and a negative rise would be down. And run, well, that's just, right, a positive run or a negative run. Okay, that's horizontal. So my rise corresponds with my y's, my runs correspond with my x's. All right? And my slope is just my rise over my run. Okay, so what would be my slope here? My slope is 1, correct? However, I need a run. I have a rise. My rise is 1. What's my run? I need a run down here. Well, I can just stick a 1 down there, right? Because 1 divided by 1 is just 1. So my rise is 1, my run is 1. So here's what I would do. I would start from my y-intercept that I plotted here, and I would go a rise of 1 and a run of 1. All right? So now I have 2 points. I could graph this at this point, but I like to get at least 3 points. All right, so I'm going to start from here. Again, my rise is 1. My run is 1. And I can go again. Rise of 1, run of 1. I like to get several points because it makes my graph more accurate. All right, so I'm going to, by the way, this coordinate grid is not completely, I didn't measure it. I didn't measure the distance between each grid line, so my coordinate grid system is going to be a little off. Hopefully it doesn't mess us up. All right, so there's my first graph. That is the graph of y equals x plus 1. All right? Now let's go ahead and graph our blue equation. Okay, as you know, is this in slope-intercept form? It's not, is it? Y has to be by itself, and y is not by itself. How could we get it by itself? See if you can pause the video and see if you can put this in slope-intercept form. All right. Well, did you see that you could just, I want to get rid of that x. That's a plus x, so I just subtract x to both sides. All right? Now I get y equals, that x is gone, equals what? What's 3 minus x? Those are not like terms, are they? So we can't combine them. So shall we go 3 minus x or negative x plus 3? Well, remember, we want our constant at the end. We want that 3 at the end. All right, so put that 3 at the end and stick the negative x out in front. Okay, now that's in slope-intercept form. Now, what is my slope? Again, I can stick a 1 in front of there. All right, sometimes there'll be a 2 or a 3 or even a 1/2 or a fraction, right? But if there's nothing in front of it, that means there's a 1 in front of it. Okay, my y-intercept. What's my y-intercept? 3. All right, so there's my slope. And there's my y-intercept. All right, so the first thing I do is I plot my y-intercept. My y-intercept is at positive 3. So I'm going to go from the origin. I'm going to go up 3. 1, 2, 3. Up because it's positive 3. All right, if things are looking up, that means they're positive, right? Okay, and my slope is negative 1. So my slope is negative 1. But again, I need a run, right? I need a fraction here. So I just stick it over 1. Okay, negative 1 over 1 is just negative 1. So my rise is negative 1, my run is 1. So I'm going to start from my y-intercept. My rise is negative 1. So where do I go? Up or down? I'm going to go down. Whoop. And you don't want to do that. You don't want to plot that point because I have not plotted my run yet. That was a rookie mistake. All right, so again, I start at my y-intercept. I go down 1, and now I got to go over to the right 1 because that's a positive 1. So that would be my point. Okay, and I can do another one. Negative 1 over 1. Negative 1 over 1. See that? And again, make sure you use a straight edge. If you don't use a straight edge, you'll be in a lot of trouble. Alright, so I'm going to go ahead and plot that. Now I guess close enough, huh? Okay, and this is y equals negative x plus 3. All right, so I plotted both of my equations. Now here's the million-dollar question. What is the solution? What is the common solution to this system? Well, let's take a look. What you have to understand is that every point along the line is a solution to the equation. Check this out. For example, see this purple line? See that point right there? That point is at 1, 2, 3, right? And 1, 2, 3, 4. So x is 3, y is 4, right? X equals 3, y equals 4. Let's see if this is a solution. Watch this. At x equals 3, so I'm going to put a 3 there, and I'm going to put a 4 here. Okay, so does 4 equal 3 times 1 plus 1? It does, because 3 times 1 is 3, and 3 plus 1 is 4, and 4 equals 4. That is a solution to the equation. So every point along this line is a solution to this equation right here. So which is their common solution? They do have something in common. And it's right there. All right? So what is that ordered pair? What is that ordered pair? That ordered pair is, well, my x is 1 and my y is 2. My x is 1 and my y is 2. So my solution would be 1, 2. Right? An ordered pair is written in parentheses. X comes first, separated by a comma, and then y. There's my solution. All right? So, here we go. You want to write this down. So the solution to a system of equations is an ordered pair, that's an ordered pair right there. It's an ordered pair that is true for both equations. That's all it is. So here's the whole lesson in 2 sentences. To find the solution to a system of equations by graphing, simply graph both equations. The point of intersection is the solution. That's it. Right? 1, 2 is true for both of these, and I'll prove it. All right? Let's see if it's true for this equation here. X is 1, y is 2. All right? This is x, y. So y is 2, so I get 2 equals x is 1. So 1 times 1 is 1. So 2 equals 1 plus 1. That's correct, right? How about this equation here? That's my second equation. Does it work? All right, y is 2. So 2 equals -1 times 1. So -1 times 1 would just be -1 plus 3. Is that a true statement? Is 2 equal -1 plus 3? It is. 3 minus 1 is 2. Okay? So, again, the solution to a system of equations is an ordered pair that is true for both equations. And you can see the solution visually on the graph. All right, I hope this video was helpful to you. Make sure you subscribe to my channel. That way you get notified anytime I make a new video. And remember, in the description below, I have the notes for this lesson. All right, so until next time, my friends, may God richly bless you.